Welcome. This presentation includes general information about the CFFDRS Fire Behavior Prediction, or FBP system. Because most of you have some knowledge of and experience with the US fire behavior prediction tools, I will try to use what you've already learned and compare this to what you already use. As shown here, the Fire Behavior Prediction System is part of the CFFDRS system of tools that includes the Fire Weather Index system explained in earlier presentations. The FBP system has been available since 1984, providing tools for firefighters and fire analysts in the field to make predictions that can inform important decisions for emerging and ongoing wildfires. You will notice that the FBP system gets its weather inputs from elements of the FWI system, specifically the initial spread index and the buildup index. The FBP system was developed from systematic observations and measurements collected from experimental burns and wildfire documentation. And when compared to the basic US system, there are a number of similarities. Fire behavior predictions are really intended to help visualize the fire before it happens, including estimates of how fast it will spread, how hot it will feel, suggesting how close you can get, and whether or not ground fire is expected. These predictions can produce estimates of how far it will spread, how many acres it will burn, and the distance required to encircle the fire. Along with other information, these predictions can help you decide what to do. From the US, the Rothermel surface fire spread model was developed in the early 70s, with additions for spotting distance and ground fire spread coming later, and a system of tools released in 1983. The inputs include fuel description, fuel moisture assessment, slope steepness, and wind speed. In much the same fashion, the FBP system includes fuel descriptions, fuel moisture assessments in the form of FFMC and BUI, slope steepness, and wind speed. Both systems can produce estimates of the final fire size and shape from an initiating wildfire. While the US system of fuel models are based on the surface fuels that carry the fire, grass, shrub, litter, understory, and slash, the FBP fuel types are based on the plant communities, conifer, hardwood, mixed wood, open, and slash, that can be recognized on site, in photos, and from maps. While the US system allows the users to define a series of tree crown inputs for crown fire predictions, the FBP system includes these definitions in the fuel types themselves. This simplifies the inputs and integrates crown fire predictions with the basic results. The FBP system uses the day-to-day history built into the FWI fuel moisture codes and fire behavior indices. This makes it much easier to obtain the inputs required and characterize important cumulative drying when making your fire behavior prediction. The initial spread index changes day to day and hour to hour based on fine fuel moisture code and wind speed. The buildup index represents cumulative drying over weeks and months and helps adjust fuel flammability and consumption predictions. But because the FWI system requires daily observations to maintain accurate values, inputs obtained from the nearest RAWS location may not represent the conditions at the fire. They may need to be adjusted. While wind is probably the most important factor in predicting fire behavior, it is the most variable and least well understood. As has been discussed in the presentation on initial spread index, and will be discussed later in the presentation, wind, slope, and ISI, the FBP system is designed to use surface wind speeds provided from a standard forestry RAWS based on the international standard at a 10-meter height above surrounding cover. It's important to understand whether your wind measurements or forecast conforms to this standard and how to adjust it when it does not. Finally, FBP tools provided in the field guides and in computer calculators provide fireline tools for good estimates of expected fire behavior, spread rates, flame lengths, and expectations for crown fire. The concepts are similar and transferable to more advanced tools used in WFDA spatial analysis. However, FBP fuel types are more comprehensive than US fuel models, defining surface and tree canopy fuels together. The FBP system uses FWI fuel moistures and fire behavior indices directly, leveraging their understanding of cumulative drying. This completes the FBP introduction. There are a series of 8 additional presentations describing the fire behavior assessment process, the important factors to put into the FBP system, the information that is calculated, and how you consider adjusting and interpreting the results. Thank you.